So we previously defined the angular momentum of a particle about any point P as r minus rp cross mv. M and v and r are the mass, velocity, and position vector respectively of the particle. So about the origin O, for example, the angular momentum of the particle HO would be equal to just r cross mv. That's because RO, the position vector to the origin, is just 0. Now, if I look at the balance of linear momentum, F equals ma, for a particle, I can derive an equation that we will call the balance of angular momentum. And that relates the rate of change of the angular momentum, h dot O, is equal to the sum of moments acting on the system about point O. We will derive this equation. Actually, for a particle, we can derive this equation from the balance of linear momentum. And it's actually analogous to the balance of linear momentum. So the balance of linear momentum says that the sum of the forces acting on the system on a particle is equal to the rate of change of linear momentum. And then the balance of angular momentum says that the sum of moments acting on a particle about point O is equal to h dot O, the rate of change of the angular momentum of the particle about O. Cool. So then, let us start with the balance of linear momentum. F is equal to g dot, and if I take the cross product, r cross F is equal to r cross g dot. So I'm just taking r, crossing it with both sides of the equation from the left. This is just the moment of the force F about O, right? Because you can think of this as basically r minus ro cross F. By definition, the moment of the force F about O. And here, on this side, we will get r cross g dot, which we do not really know yet what it is. However, let's go to the side and discuss h dot O. Remember, HO is equal to r cross mv. So to calculate h dot O, I have to calculate the derivative of this cross product. So we call that the derivative of A cross B is A dot cross B plus A cross B dot. So a simple product rule applies. So that's equal to V cross MV plus R cross MV dot or MA. Now what is V cross MV? That's the cross product of two parallel vectors. And we know that the cross product of two parallel vectors is just the zero vector. So that's 0. And that's just R cross MA, which is R cross G dot. Awesome. So now we know that this term, R cross G dot, is equal to H dot O. And we've derived the balance of angular momentum for one particle. We can only derive the balance of angular momentum from the balance of linear momentum for one particle. Later on, when we talk about systems of particles and rigid bodies, those two laws are going to be completely independent. We cannot derive one from the other one. That's why we will call the balance of angular momentum Euler's second law, completely independent from Newton's second law or Euler's first law.